Welcome to qnawire.
Welcome back to Numerad. My name is Kevin Chirac. So in this problem here, we have an 80-kilogram fireman slides 5 meters down a fire pole. He holds onto the pole, which exerts a 500 Newton steady resistive force on the fireman. At the bottom, he slows to a stop in 0.4 meters by bending his knees. What can you determine using the information? And let's figure that out. Well, we can find out the acceleration at the final part of the trip during the 0.4 meters is about 41 meters per second squared. And so let's figure out how it is that we get there. The first thing to consider is a free body diagram where we have a resistive force that's pointing upwards, and then obviously the force of gravity that's pointing downwards. We can use Newton's second law to say the sum of the forces is equal to mass times the acceleration net. And so from here, we can simply calculate out that the forces that we have are going to be the resistive force, that's that 500, we'll plug that in just a second, and then subtracting that Fg equal to the ma net. Very nice. Now what we can figure out from here, we can replace the Fg with m times g. We have the ma net still, and the force. Let's go ahead and plug in some numbers. We have 500 minus 80 kilograms in SI unit times 9.8 equals m, which again is going to be that 80 kilograms, times the acceleration net. So we can simply solve out for that. This will be 500 minus 80 times 9.8 and then divided by 80 equals 3.55 meters per second squared. In fact, it's going to be a negative 3.55 meters per second squared. And so what that just simply means is that the acceleration downwards is going to triumph over the upwards acceleration. So we have a nice acceleration there. Now the next part we can figure out is that with all of this information, what the final speed was at the very end. So we're kind of doing a little bit of a bonus here. So we have Vf equal to Vi plus, I wanted to say At, but we don't actually have the time here. So let's transform this into Vf squared plus Vi squared plus 2 times A times delta x. And we just calculated for the A net during the first portion. And we know that the initial velocity is going to be 0. So we can say that Vf is equal to the square root of 2 times 3.55 and then times that delta x, which is 5 meters. So let's plug that in. That'll be 2 times 5 is 10. Actually, multiplied by this would be 35.5. That would need to be square rooted to get us our final velocity. So the square root of 35.5. We'll just plug that into the calculator. And that comes out to 5.96. So 5.96 is going to be the final speed after the first part of the journey. Now the next thing we can do is figure out that if that's my final speed from the initial part, what's the acceleration required for the second part to bring this down to a 0 velocity? Well, again, we're going to use something like Vf squared is equal to Vi squared plus 2 times A times delta x. This time, however, we are talking about the second part of the journey, so let's write that as a delta x2, and we have a second acceleration, so we'll write that. Our Vi squared is actually going to be equal to the Vf squared from before, and our Vf squared is going to be a new one. So perhaps we'll write something like a prime, although I'm a little hesitant to do this because sometimes that prime can make it look like a 12th power instead of a prime to the second power. But either way, right now we'll know what we're talking about due to the commentary. 5.96 squared is actually going to go back to that 35.5 that we had earlier. And then again, it's going to be plus 2 times A, which we don't know, and then times delta x, which is going to be that 0.4 from before. So let's go ahead and plug all of this in. This is going to be 5.96 squared. And then we're going to be subtracting that over to the other side of the equation, dividing by 2, and then dividing again by 0.4. And that'll get us a final acceleration equal to 44.4 meters per second squared. So actually a little bit off from our earlier estimate. We got 44.4 here. And then the last part we can figure out is what the overall force is. The force is going to be that mass times the acceleration, too. So it's going to be then the 44.4 that we had from before times 80. So we're just going to multiply the answer we just got by 80. Times 80 is going to be 3,552 newtons. So we're going to go ahead and scroll back down here. That'll be, oh, too far. Technical difficulties. There we are. Force is equal to 3,552 newtons. And that'll be, again, during the second part of the trip. I hope you enjoyed this video. If you did, please take a moment and click that heart at the bottom.